Now this one's a little bit different because we actually have an equation instead of just random data points. So the graph is f of x equals x squared plus x. Consider the region that's bounded by the graph of f, the x-axis, and the line x equals 2. So over here. Yes. All right, divide the interval 0 to 2 into 4 equal subsections. Okay, but we're only going to use 4 equal subsections. So what's going to be the width of each section? 0.5. Good. So we're going to kind of cut it off at 0.5, at 1, 1.5, and then 2. All right, draw the rectangles that you would use to calculate the upper and the lower estimates. I'm going to do upper first. So upper, that first interval, would that be reasonable? Okay. And then between the other two, like that. Okay. Is this a left or a right estimate? Good, right. Okay, the lower ones. What's the height of the first rectangle if it's a lower estimate? 0. Now, how? Okay, so we're going to use upper. I'm going to do my work for part B up here. Lower is left. Okay. Actually, I'm going to do the lower one first just because I'm in that color pen. What's the width of every single rectangle? 0.5. Now, how on earth am I going to find the height of each of those rectangles? Yes, I'm going to plug it into the equation. The height of my first blue one is 0. Okay, but the height of my second blue one, how am I going to find that out? Okay, that's right. We're going to use our calculators. And the most effective way to use your calculator is to graph. Oh, sorry. Okay. Part B asked for the upper, so we'll do the upper. I'm sorry. Either way, we're going to type our equation into y equals. And the equation was x squared plus x. And I think the easiest way to deal with this is to look at the table. So we need to make sure that the table is set correctly. So I'm going to go to diamond F4. In order to find those values at x equals 0, 0.5, 1, 1.5, where do I want to start my table? At 0. And what do I want my change in table to be? 0.5. You could make your change in table 0.25, but we're only really interested in the heights at 0 and 0.5, 1.5, and at 2. So there's just kind of less clutter on your screen. Make sure you hit enter enough times. Okay. So if we do our upper bound, then the height of the first rectangle was 0.75. And another trick, you need to highlight the y column because if there's not enough space to put all the decimals in the actual table, when you highlight it down there on the bottom, you'll see it. And remember that your final answer has to be accurate to 3 decimal places. So these numbers right here you should take to probably 5 decimal places. Okay, so the height of the first one's 0.5. What's the height of the second one? 2. And the height of the third one? 3.75, and then 6. All right, so the width of each rectangle is 0.5, and then the heights from the table were 0.75, 2, 3.75, and 6. If it doesn't give you any units, you don't have to do units. Okay, part C says find an approximation for the area using the trapezoid method. It's going to be like this. So the area of each, or the area of a trapezoid is 1/2. The height is 0.5. All right. What is the length of this first base right here on the left-hand side? 0. Okay. The second base is the height of the curve at 0.5. But I need to do that one twice. Okay. And so that height was 0.75. And then the next height was 2. And then 3.75. And then I can close my parenthesis, and the last height was 6. And we get 4.75. All right. Is my estimate to part C using the trapezoid method, is it too big or too small? All right. From here to here, if I were to draw that trapezoid, okay, so too big or too small? Too big. Why? Okay. Because f of x is concave up. Yes, that's your reasoning like a justification. That answers why. Why is your estimate too big? Because f of x is concave up. And the last question on number 5 says use a midpoint Riemann sum to find the area of this region. All right, there are basically 3 types of Riemann sums. The left, right, / upper, lower, that's all one type of Riemann sum. So that's one. The trapezoid method is the second one, and the third method is the midpoint method. The way that the midpoint method works, and we're divided into 4 equal subsections. So our rectangles are like this. But the way that the midpoint method works is that we take the height of the curve at the middle of the interval. So where is the middle of my first interval? At 0.25. So that is where the height of that rectangle is going to go. Okay, we'll do it again. Where is the middle of the second interval? 0.75. So I want to look at the height of the curve at 0.75, and that is going to be the height of the rectangle. The question is, wouldn't you get the same answer as if you use the trapezoid method with double the integrals? And the answer is no, because there's some curvature to this graph, and it's not a straight line. I'm not sure if that satisfactorily answers your question, but the answer is no. All right, and then my last interval, the middle of the interval is at 1.75, so the height of the rectangle would be right there. Okay. So I need to find, what's the first x value that I need the height of? 0.25. So I need to go to my calculator. So what's the first x value that I need a corresponding y value with? At 0.25. So under table set, what should I start my table at? 0.2. No, I want to start it at 0.25. Okay, we could start at 0 and do the delta table at 0.25, but in my opinion, you're going to have more things on your table than you actually need, and so that might be a little confusing. I think it's easier to start it at 0.25, and what should the delta table be? 0.5, because we're only interested in the heights every 0.5. Okay, so I'm hoping that you have this on your calculator, and then I'm going to switch back to the screen for the Riemann sum. What's the width of every single rectangle? 0.5. Okay, the height of my first rectangle is when x is 0.25. Someone read to me the height. 0.3125 plus when x is 0.75, what is y? Okay, when x is 1.25. And then is it 4.8125? Yeah. Okay. And if you add all of those up, you should get 4.625. Now, the midpoint and the trapezoid are going to be fairly similar to each other. Let's see, on the trapezoid, we got 4.75. So this was midpoint, and trapezoid was 4.75. Now, as to which one is more accurate has to do with a lot of things. It has to do with how fast the graph is either increasing or decreasing, the concavity of the graph. It's not something we're ever going to talk about as to which one is is midpoint or trapezoid more accurate. We won't ever talk about that. But they're both fairly accurate. Emily, did you have a question? Oh, this one is 2.8125? Okay. Actually, I think you're right, because looking at the graph, it's definitely below 3. Thank you. Okay. All right, so that's how you do the midpoint. This is an actual question from an actual AP exam. All right, they have presented to you the data in 2 different ways, and that's kind of nice. They've given you a table, but they've also drawn the graph. So they're being kind of nice here and making sure that everyone is comfortable with how they're giving it. Some people like it more in graph form. Some people like it more in table form. So the graph of the velocity of a car traveling on a straight road is shown above. A table of values for v of t at 5-second intervals is shown to the right of the graph. Basically, they just took the table and they graphed them and connected the points with a smooth curve. All right, part A. During what intervals of time is the acceleration of the car positive? What is that the graph of? Velocity. Okay, what is the relationship between velocity and acceleration? Okay, so acceleration is the derivative of that. So we want to know, if it's asking for where the acceleration is positive, I want to know where the derivative or the slope of that graph is positive. So what would you say? Okay, where the graph is increasing, so between what time periods? Okay. Between 0 and 35. Yes, you may either write it as an interval. Actually, I kind of like that better. Okay. Where else is the acceleration positive? Okay, 45 to 50. Now, I need to, it says justify your answer or give a reason for your answer. I have to give my reason in terms of what they gave me. Okay, but it's not f of x that's increasing. What did they name it? Good. The justification is because v of t is increasing. Okay, good. All right, find the average acceleration of the car in feet per second squared over the interval between 0 and 50. Okay? Did we draw a secant line? What do y'all think? Yes, that's exactly what we're going to do. The average acceleration would be the average slope between x equals 0 and x equals 50. Or the slope between your two endpoints. So we can use our chart if we want, or you can use the graph, but we're just going to do difference of y over difference in x. So 72 minus 0 over 50 minus 0. 72 over 50 is a perfectly acceptable answer. If you want to reduce it, be my guest, but you don't have to. Okay, part C. Find one approximation for the acceleration of the car in feet per second squared at t equal 40. So could there be more than one answer here, do you think? Yeah, it just said find one approximation. Okay, what are they actually asking us to do? Approximate what? The slope at t equal 40. Okay, so on the graph, I'm right here. So I'm trying to approximate this slope. Well, they want you to use known data points to approximate the slope. So does anybody have any idea how I could approximate that slope with known data points up there? Okay, I could find the slope between 35 and 45 because 40 is right smack dab in the middle. There are actually three acceptable answers. One of them is to find the slope between 35 and 40. Another one would be to find the slope between 40 and 45. And the third one would be to find the slope between 35 and 45. So you can either do, I may have already said that one, you can either do the 2 points on either side of 40, or you can do 40 and the left point, or 40 and the right point. Personally, I always take the 2 on either side. Okay, so I'm going to find the slope between, 35 and 45. So difference in y's would be 60 minus 81 divided by 45 minus 35. So negative 21 over 10 feet per second squared. Part D, approximate. Now that's a new symbol for you. I'm actually going to introduce you to that symbol in just a minute. But what that means, that's an integral symbol. But what the integral means, what this symbol means, is the area under the curve of v of t from x equals 0 to x equals 50. Okay, that's what that symbol means. So D is asking us to approximate the area between v of t and the x-axis between 0 and 50 with the Riemann sum using the midpoints of 5 subintervals of equal length. Okay, so let's do that. All right, I'm going to use 5 subintervals of equal length. So what's the length of each interval going to be? 10. Okay, so I'm going to go from 0 to 10, and then 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So the width of each rectangle is going to be what? 10. Okay, now the height, since I'm using a midpoint Riemann sum, I am going to, so this is my first interval. If I'm using a midpoint Riemann sum, then I'm going to take the height at x equal what? 5. Right. And if you wanted to draw in your intervals, you can. Or your rectangles, we can just use the chart here. What is the height of our first interval at its midpoint? 12. Okay, the second interval, what's the height? 30. And then 70, 81, and 60. So I'm going to take 10 times the sum of those heights. Okay, and turns out when you add all that up, you get 25/30 30. Yeah, that is all the work you need to show. Okay. Now, the second part of that question says, explain the meaning of this number using correct units in terms of this problem. Okay, it is feet. Okay, it is the distance that the car travels. Very good. The distance the car travels, that's not how you spell car, in feet over the 50-second interval. You will not get all of your points if you don't put over the 50-second interval. And you are going to have AP review question after AP review question after AP review question on that, explaining the meaning of that. And some of you, after 5 times, will still not put over the 50-second interval. And I will count off every single time. So you have to say the amount that it travels, but that 0 to 50 means it's over the 50-second interval.